This section is about deserts. Section 7, we are moving to a dry climate, which covers 30% of Earth's land area. And I would like you to watch this video to visualize the key terms of this section.
This is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the two principal causes for the formation of deserts. This is a map showing the distribution of desert lands around Earth's surface. You'll notice that in the Americas, they tend to be located in the mountainous west. In Africa, there's two main belts, one in the north, one in the south. In the middle of Australia and in the middle of Eurasia, there are also very large desert regions. In every place, the desert regions are surrounded by steppe regions, which are semi-arid. Why do we find dry lands in these particular locations? There are two reasons. The first one is because of the circulation of air in Earth's atmosphere. Now, you know the equator gets hit most by the sun, which means it tends to produce lots of warm air, and that warm air rises away from Earth's surface. As it rises, it takes with it a load of water vapor, and that water vapor cools off at higher levels in the atmosphere, causing it to condense and then precipitate. So the tropics tend to be very warm and very wet. Now, the air, freshly devoid of water, ends up moving away from the equator in these big, large-scale convection cells. These tend to sink again at about 30 degrees north and 30 degrees south of the equator. So this produces the so-called subtropical high. It's called high because it's a high pressure zone because of all that air cascading downward from higher levels in the atmosphere. Now, that air is very dry, so it tends to produce belts of desert in the regions where it sinks towards Earth's surface. This is certainly the case in Africa. In the famous blue marble image, you can see basically there's a large belt of desert that extends across northern Africa and the Arabian Peninsula, another belt of desert across southern Africa, and you'll notice, of course, there's no clouds in those regions either because there's very little water vapor in that descending air. And then along the equator, which runs through the middle of Africa about right there, there's lots of clouds, and in the few places where you can see below the clouds, there's dark colors indicating the forest that's growing thanks to all the rain that falls in that area. The other reason that we get deserts is due to the rain shadow effect. And this is certainly the case in California. In California, the source of the precipitation is that it's coming off the Pacific Ocean. So as it moves eastward off the Pacific, a little bit of precipitation gets wrung out as that air mass passes over the coast ranges of California. Basically, the mountains there force the air up to a higher elevation. At that higher elevation, it's colder. That causes water vapor to condense out of the air and potentially to precipitate. Then it passes over the relatively low-lying Great Central Valley, and because there's no obstacles there to force it up to higher elevation, you don't really have a whole lot of rain in the Great Central Valley. But then there's a very big obstacle indeed, and that's the Sierra Nevada mountain range. The air masses moving over the Sierra Nevada get forced up to really high elevations. That means that the water vapor is more likely to encounter cold temperatures and therefore to condense and potentially precipitate out of the atmosphere. By the time the air gets over to the far side of the Sierra Nevada, out into the Great Basin, basically has had all of its water vapor wrung out of it, and there are no more really high obstacles to extract rain from that air. As a result, the western slopes of the Sierra Nevada look very different from the eastern Sierra. Let's go ahead and take a look now at another U.S. state. This is the U.S. state of Washington. Eastern Washington state is an example of a desert. Does this look like it would be an example of a rain shadow desert or a desert that's due to the large-scale convection that is observed in Earth's atmosphere? Well, you've had a minute to think about that. It's not really right there on that subtropical high, and so you wouldn't expect this to be a desert caused by convection in Earth's atmosphere. However, we have very good evidence that suggests that this is in fact a rain shadow desert. As with California, the source of the water is coming off the Pacific Ocean in the air, and you can see when it encounters ranges of mountains, such as the Olympic Mountains or the Cascade Mountains, you see there's lots and lots of precipitation there. And as a result, eastern Washington is a desert because of the rain shadow effect. Thanks very much for your attention. This has been another Smart Figure.